We are delighted to welcome you back to the Crystal Clear Electronics videos. We will continue to expand our knowledge of the multimeter with Béla Danyi.
After learning about the general design and correct wiring of the multimeter in the previous video, we will first look at voltage measurement. Note that in the studio, we use a USB multimeter so that you can see the measured values live. Let's start with the simplest case, which is DC voltage measurement. We can measure the voltage between 2 points. In this case, the multimeter is always connected in parallel to the components or equipment to be measured. The voltage meter is considered to be ideal, so it works as an open circuit, no current flows through it. In reality, of course, the measuring instrument does not behave as an ideal open circuit, but as a high-value resistor, which is usually noted on the instrument by the manufacturer. That's 10 megaohms in case of my multimeter. While the resulting resistance of the measured circuit network is below 10 kiloohms, the input resistance of the multimeter is infinite, and the multimeter is considered to be as an open circuit. However, this value depends on the type of the multimeter.
What if the resistance of the component you intend to measure is close to the resistance of the multimeter?
Of course, we can measure in that way too, but the measurement will be more inaccurate and the operation of the circuit will be more and more different from the original. We will discuss the reason and theoretical background later when we will discuss the parallel connection of resistors. Turn the rotary dial from the off position to the right clockwise, where DC voltage can be measured with a 20 volt measurement limit. The measurement limit should be chosen so that it is set to the lowest possible value, which is definitely greater than the value to be measured. In this way, we can measure the most accurately. Modern digital multimeter protection against overvoltage is generally good. If we accidentally choose too small measurement limit, then no serious trouble can happen. In this case, the multimeter with 1 on the left side of the display indicates that the signal to be measured is greater than the selected measurement limit. Gergő, please help me and let's start by measuring the voltage of our small 12 volt power supply.
I quickly plug the power supply into the breadboard. Here we can see that we are measuring 12.2 volts.
Could you show us what happens if we use reverse polarity? How does this look on our multimeter?
In this case, a negative sign appears before the value. This does not cause any problems for the multimeter, but the user has to be able to interpret it.
I know, Gergely, you're already confident with the multimeter, but for the sake of the viewers, I would like to give you some good advice on what to look out for when measuring the voltage of such a small power supply. It's important to pay close attention not to short circuit the power supply with the metal tips at the end of the measuring cables when measuring between points near each other. Always take care that the probe only touches the selected point in the circuit. If one of the tips reaches the circuit inadvertently between more points at the same time, then these points will be short-circuited, which usually does not mean danger to the measuring instrument, but can damage the circuit or the power supply. If we are not sure, let's put 2 wires to the breadboard. Connect one to the negative line, rail, and the other to the positive line. Then, touch the black measuring cable to the negative terminal and the red to the positive terminal, or to the end of the corresponding newly connected wires. Make sure that the contact between the measuring cable and the point being measured is correct during the measurement. If the value on the display fluctuates significantly, the contact may not be correct. If we did everything well, our instrument would show about 12 volts. In my case, it was 12.15 volts.
I would only add that the newer types of multimeters come with these protective measuring tips, and when you put them on the end of the measuring lead, the metal part that sticks out is so tiny that there is very little chance to cut anything short. If you can, always use these insulating gauge tip protectors.
If we got this, then measure the voltage at 2 resistors connected in series. Take 2 1 kilo ohm resistors and connect them in series and to the power. Then measure the voltage at the 2 resistors.
Mérjük meg az ellenálláson eső feszültséget.
We need to get the same value as in the previous measurement, the power supply. And we really got that with a difference of 1 to 2 hundredths of volts.
Eltérés, de ez bőven belefér.
Then, measure the voltage at one of the resistors. Because they are connected in series, we are expecting that the voltage will be divided by 2 and we will get around 6 volts.
És valóban 6,8 volt körül értéket mérünk, ami tényleg jó közelítéssel a tápfeszültségnek a felét. Ugye másik.
Can you measure the other end?
Yes, and this is 6.1 volt.
Great, thank you. Now, replace one of the 1 kilo ohm resistors to 100 ohms. Then the voltage at 100 ohm is 1.11 volts.
1,11 körüli értéket ad. Ez a szám.
This is the calculated value. Now let's make the measurement and compare the two values.
Let's measure the power source first.
Ott is van.
You can see it here. Then measure the voltage across the 100 ohm resistor.
Akkor
And here again, we can measure the calculated voltage to 1.1 decimal value.
A tananyagban szereplő
In the case of the multimeter in the textbook, it would be worthwhile to switch to the 2000 millivolts measurement limit here. In our case, the machine did it for us because it is such a good machine that it sets the correct measurement limit by itself. We did not have to do that this time. By adjusting the measurement limit, we can gain another valuable mark and get a more accurate result. You could notice that the calculated and measured results are slightly different. The reason for this is that the true value of the resistors differs from the nominal value due to manufacturing inaccuracy. That is, what is written on it, and that our instrument also has measurement inaccuracy. At resistance measurement, I promised that we will refine our previous calculation. If you like, find out more examples of serial parallel connections, calculate them, and control them by measurement. In summary, I would say a last sentence. It's easy to measure voltage, but attention should be paid not to short circuit with the metal tip of the measuring cable nearby metal surfaces, otherwise the measured equipment can be destroyed. During the measurement, we can measure using the red cable relatively to the point we touched with the end of the black measuring cable.
Thank you, Béla. I think that those of you who followed us through the video will be more willing to do some voltage measuring on your own. In the next video, we'll look at current measurement. Adios!